Now we are going to see Arduino. So what is Arduino? Arduino is an open source hardware and software prototyping platform where we can do miracles in electronics. So what is this open source? Open source in sense everyone can modify the existing one. Actually Arduino was prepared by Massimo Benzi from Italy, and he told that Arduino is open source. So everyone is trying to modify the Arduino and they came with different versions of Arduino. So to program Arduino, we should require Arduino software and also a Arduino board. So before seeing Arduino board, we should look some theory of microcontrollers because microcontroller is the heart of Arduino board. So the first microcontroller was invented by Intel in 1970s. The name of the microcontroller is 4004. It is a 4-bit microcontroller. After that, they came with 8008 microcontroller, 8-bit microcontroller. So the drawbacks of 4004 and the 8008 is overcome with 8051 microcontroller, which is a basic and popular microcontroller from the Intel. So at this time, one more company called Atmel started working on the microcontrollers, and they come with some other microcontrollers, that is they are AVR microcontrollers. So in AVR microcontrollers, there are some thousands of controllers, thousands of versions are available. The only difference between all the controllers is their RAM and ROM size and also input output pins. So the basic AVR microcontrollers are Atmega 8, which is 8-bit microcontroller, Atmega 16, it is also 8-bit microcontroller, but the ROM size of Atmega 16 microcontroller is 16 KB. Coming to Atmega 8, the size of the ROM or flash memory is 8 KB. And other popular microcontroller is Atmega 328. This is the controller used in the Arduino board. So it is having 32 KB of internal memory or flash memory used to store the program and 2 KB of RAM. So like that, Atmel invented different types of microcontrollers. So why Atmega 328 has become more popular with Arduino is actually to program this kind of microcontrollers 8008, 8051 microcontroller. First we have to select a programming language. After that we have to write the program. After writing the program, we should generate an application by compiling the program. After generating application, we should upload this application to the microcontroller by using some other hardware programmer. So by using a hardware programmer, this application is going to dump into this 8051 microcontroller or 8008 microcontroller. So these are the many steps involved in programming the 8051 microcontroller. So all these steps are overcome by a single step, by using Arduino. In Arduino, just write the program and hit upload. Then the program will sits into your microcontroller. There is no need of compiling and there is no need of uploading using external programmer. Simply by connecting USB cable to your laptop into the Arduino board, you can program the Arduino board. So coming to Arduino, Arduino was invented in 2005. 2005 by Massimo Benzi. Why it has got name Arduino? Actually, the founders and co-founders of Arduino used to meet at one bar called the Arduino in Italy. So they named the board as Arduino. And after inventing Arduino, they told that it is an open source one. Everyone can modify without any permissions or any rights. So at that time, some other person started working on Arduino and he come with some more board that is Arduino. So one more board that is Arduino Uno. Later, Arduino Uno is modified into some other one that is Arduino Mega. Like that, many different flavors of Arduino available in the market. So here I'm going to show some of the flavors of Arduino boards. Here you can see Arduino Uno, Arduino Leonardo. So Arduino Uno, Arduino Leonardo. The main difference between these two things is here it is having one type of different type of USB port to program the controller. Here it is having micro USB. Remaining things are same. Here you can replace the controller if it is damaged. Here it is not like that. So like that different flavors are available. Here you can see this Arduino Mega which is having more number of input output pins. Say for example, if you are making a complex or huge project which is having more input and output devices, at that time we have to select Arduino Mega. If your project is simple, you can go with Arduino Uno. So according to the application, you have to select the Arduino board. If you want to connect your Arduino board to the cloud, you have to use Arduino Ethernet, where you can connect a LAN cable to the LAN port, and also you can interface a SD memory card and you can make a data loggers. So if you are making a smaller one, lighter project, you can go with Arduino Nano. So it's all depends upon your application. So the basic and beginner friendly board is Arduino Uno. So we are going to focus on Arduino Uno and we will see what is the microcontroller present on the Arduino Uno and what are the specifications of this board, how many input output devices can we connect maximum, and how to program this Arduino Uno. So this is how Arduino Uno board looks. As we already know that microcontroller will take input from the input devices and generate output on the output devices. For that purpose, it should require some input and output ports. So coming to Arduino Uno, it is having 8 mega 328 microcontroller as its base. This microcontroller is 28 pin microcontroller. Now we are going to see the pin diagram of the microcontroller Atmega 328. This is the pin diagram of Atmega 328. So if you observe, it is having 28 pins, 14 pins left side and 14 pins right. So this microcontroller will work with 5 volts. We already discussed how to get 5 volts. So it's from RPS. On board there is one small RPS circuitry where this microcontroller will get 5 volts from from the source. That 5 volts is given to VCC and ground pin of the Arduino or Atmega 328 microcontroller. So coming to remaining pins, this here you can see 9th and 10th pin is connected with crystal. Crystal in the sense there is one external crystal oscillator which helps the controller to synchronize the internal operations. So it is acting as a clock for the controller. Coming to input output pins, Arduino is having 20 input output pins. Out of 28 pins from this microcontroller, 20 are input output pins. Out of 20, 14 are digital pins and 6 are analog pins. Here you can see digital pin starts from here. Digital pin 0, 1, 2 up to 4, and here you can see some more digital pins. So total we are having up to digital pin 13, means we are having 14 digital pins where you can connect digital sensors or digital devices to these pins. And coming to analog, we are having 6 analog pins. So 14 plus 6, 20 input output pins. To these analog pins, we have to connect analog sensors. If you are taking analog data from the sensors, you should connect that particular sensor to the analog pin of the controller. Say for example, you are going to monitor the temperature. Temperature is analog in nature. So that particular temperature sensor should connected to one of the analog pin. Say for example, I have connected my temperature sensor to analog input 0. Here I am connecting a temperature sensor, analog pin 0. The thing I have to do is I have to write a program for this controller to monitor the analog pin input 0, this pin, so that I will get the temperature values from the sensor. So the digital pin are denoted by 0, 1, 2, 3, 4 up to 13. Coming to analog, they are denoted with A0, A1, A2 up to A5. So total 6 analog pins are there. So this Atmega 328 is having inbuilt ADC. So this analog data is going to convert into digital, which could understand by CPU present in Atmega 328 controller, and it is having 32 KB of flash memory to store the program and 2 KB of RAM, and it supports full duplex serial communication using these two pins, digital pin 1, 0 and 1, RX and TX. So full duplex serial communication can be happened through this pin. And the first pin is important one, that is reset. Reset button is used when you want to execute the program from starting. Say for example, your program is executing and your program counter is at middle of the program. At that time, if you press reset button, your program starts executing from first, and you can see here ground A reference and a VCC. These three are used to power up the analog to digital converter present in the Atmega 328 microcontroller. So to power up the CPU and other peripherals, we are going to use 7-8 pins. To power up the ADC, inbuilt ADC in the controller, we are going to use this AVCC, A reference and ground. A reference is the reference voltage for the ADC present in the controller. And also this microcontroller can have the feature of SPI, serial peripheral interface. So on 10th, 11th, 12th, 13th pins, these three pins are used for serial peripheral interface, and C5 and C6 are used AZ. These two A4 and A5 are used for I2C. By using these two pins, this controller will form a bus called I2C inter-integrated communication. By using that bus, this controller can communicate with other controllers. Like that, many controllers can communicate on one bus. That is I2C. Now we will see the board description of Arduino. I think you are clear with Atmega 328 pin diagram because this is the controller present in the Arduino Uno board. So this is the Arduino Uno, this is the Atmega 328P microcontroller. As I already told you that it contains 14 digital pins and 6 analog pins. Here digital pins are there from 0 to 13. Total 14 pins are available. 0 to 13, 14 digital pins. And coming to analog, it is having A0 to A5. Here it is denoted with A0 to A5. Here we can connect the analog sensors, and these are the digital pins. This is the power connector. So if you are connecting any sensors to this board, every sensor will have three terminals. We already know that. So say for example, this is the temperature sensor. You want to read the temperature. So at the time, I'm going to connect this temperature sensor to one of the analog pin. To power up this sensor, we require 5 volts. That 5 volts is taken from power cable. Here you can see 5 volts, and ground is connected to ground. Like that, we have to connect external devices to the Arduino board. So these 5 volts and ground are used for connecting the sensors or other peripherals for the Arduino. So this is the power source for the Arduino board. Here you can connect any voltage. That particular voltage is going to convert into 5 volts. This is the voltage regulator. This voltage regulator will convert that voltage into 5 volts. These two capacitors are used to remove the voltage fluctuations. And finally here it will get 5 volts. This 5 volts is given to the Arduino, that is Atmega 328 microcontroller. So this is the USB port where you are going to program your board using a small USB cable. So first we have to write program in the computer in Arduino software. After writing, connect the board with the USB cable and hit upload in the Arduino software, so that the program will be sent to this controller via this FTDA chip, level converter chip. Here you can see the status indicators for transmitting and receiving. Whenever Arduino is communicating with one other device or other Arduino through serial communication, By using these indicators, you can see the status whether it is transmitting or receiving the data. So while programming, the program will enters from the USB to FTDI level converter chip. After that, they will the program will sits in the controller with the help of 0 and 1. This is TX and RX pins. And this is the crystal oscillator which is connected to 9th and 10th pin of Atmega 328 microcontroller. Helps to synchronize the internal operations. And this one is the reset button. Whenever you press the reset button, the program is going to be reset and it will start again. Here one more LED which is connected to 13th pin, 13th digital pin of the Arduino. It is onboard LED. So our first program is to blink this LED, and also here you can see ICSP. These pins are used for connecting external programmers with SPI interface, and these 6 pins are used to upgrade the firmware version in this IC FTDI chip. So this is the switching button, automated switching device, where if you connect power supply using this power cable, it will switch the power supply from this cable. If you connect USB cable, it will switch the power supply from this USB port. Like that, switching will be happen automatically by using this switching device. So now we have done with board explanation, that is hardware of Arduino. Now we will see software of Arduino. What is the software we have to use for Arduino? So to program Arduino board, we should require a software called Arduino IDE. IDE in sense in integrated development environment. So it is nothing but a mixture of text editor, compiler, and debugger. So it's a mixture of some tools, that is text editor where it is helpful for writing the program, compiler to know the errors and to compile the program, and also debugger to debug the program. So Arduino IDE contains mainly these three things. So as I already told you that Arduino is open source and freeware software available in Arduino official website, that is arduino.cc. From this website you can download latest Arduino version, Arduino IDE version. After downloading Arduino, you should download some other software, some other drivers for Arduino board, that is CP210 drivers. So if you want to program Arduino board, you should install these drivers in your PC so that PC and Arduino will get connection and they will communicate with each other. So latest Arduino boards doesn't require these drivers. Directly, if you connect Arduino board, your PC is going to detect the Arduino board and it will assign some COM port to the Arduino board. So after downloading the software, install the drivers if required and open the text editor write the program and hit upload, so that the program is going to upload in the microcontroller or Arduino board. So Arduino programming language is very easy because it's purely based on C, C++, Java. If you know the basic syntax of using C, you can easily write or you can easily code Arduino board. So generally we are writing C programs or some other programs to develop applications. Say for example, if you take Android mobile, it contains some applications to which already someone has written some source code for that application. So here now we are going to write source code for our application, and finally we will generate some application and we'll upload that application in the Arduino board. Now before writing our first program, you should know the difference between C and embedded C. So normal C language is used to develop applications for computers or some other systems, but coming to embedded system, embedded C programming, they are used to develop applications for target boards like microcontrollers and microprocessors or some other boards. So we are going to see the difference between C and embedded C. Before going to see the differences between C and embedded C, we should look the body of the C language, how a C language looks. Every C program will starts with header file part. So here commonly we are using standard input output.h. So if you are including this stdio.h, means you are including standard input output library so that you can have access to input output functions present in this library like printf and scanf. After that we will go with global declarations if required. After global declarations we will start with our main function, which is starting point of the program. After main we will declare our variables. After declarations, if there is any requirement, we will initialize the variables. After initializing the variables, we are going to write logic part, and finally we are going to terminate the program. This is how a normal C program looks. Coming to Arduino programming, it's very simple. Arduino program contains only two functions, that is setup function and loop function. Here loop function is nothing but a infinite loop which is while one. So every embedded system should do a task for infinite time. So here the logic should be placed in the infinite loop so that the logic is keeps on rotating for infinite times and it will appears like continuously working. So in setup function you should we should set up the hardwares. So in normal C program we declared the variables. Say for example you are writing any addition or subtraction programs, first we have to declare the variables. Similarly here we have to declare the pins. Coming to Arduino, we are already know that it is having some 14 digital pins and 6 analog pins. Starts from A0 to A1. Say for example, I want to blink the LED which is connected to 13th digital pin. For that purpose, I have to tell the Arduino that I am going to convert a LED to 13th digital pin. So this can be done by using pin mode function. By using this pin mode function, we can tell that Arduino I'm going to use 13th digital pin as output. If I am connecting output device, say for example, if you are connecting any sensor to the 13th pin, we have to declare as input, so that Arduino will consider that particular pin as input. So by using pin mode function, we are going to tell the Arduino whether that particular pin is using as output or input. So all the hardware connections should be mentioned in the setup function. Say for example, I have connected a motor to 15th and 6th and 7th pin of Arduino. Simply I have to mention like this: 5 comma output, so that Arduino will understand that 5th and 6th pins are using as output pins. So we will consider one more example. I am going to connect a temperature sensor to analog A0 pin. At that time, I should declare that A0 as input, because sensor is input device. By using this pin mode function, we can declare. So I'm going to declare input like this. So this is how we can declare the pins, because here in this program we are not having any variables to do logical operations, just we are having only pins, 20 pins. So the 20 pins should be declared in setup function. So setup function is mainly for hardware setup. After telling the Arduino about input and output devices in loop part, which is logic part, you have to write the logic. So our first program is to blink the LED connected to 13th digital pin of Arduino. So by using pin mode function, I am declaring 13 as output, because LED is output device. After that, by using logic function, I'm going to blink that LED. Blinking in sense just turning on the LED for 1 second and turning off the LED for 1 second. So to turn on that particular pin, to make that particular pin as high, we should use one more function, that is digital write 13 comma high. Means I'm going to make this 13th pin as high by using digital write function, and I will wait for some time. By using delay function, I'm going to wait for 1 second. 1 second means 1000 milliseconds. So here I'm going to set 1000 milliseconds in the delay function. So after that, I will turn on the LED by using same digital write function, and I will wait for 1 second. So when control comes to this statement, LED will on for 1 second. Wait for 1 second. And LED will off for 1 second. So after writing the program, just hit verify. If there are any errors in the program, the IDE will show the errors. If there are no errors, it is compiled successfully and it is ready to upload into your Arduino board. So this is the basic program which can blink the LEDs. So first we have interfaced our output device. Next we will see how to interface input devices. So this high can be replaced with 1 and low can be replaced with 0. So here high is nothing but 1 and low is nothing but 0. So every time we can use 1 and 0, which will reduce the complexity in the program.